Hello students, this is a program, Python program for linear search. So what is search? Searching. Searching means we can find a data. If you want to find a data from a given set of data, then we can use some searching algorithm. So one algorithm is linear search. So this is a list. So it stores some data. 3217689. Seven data are there. So here the index starts from 0 by default. So this is list of 0, this 2 stored in list of 1, list of 2, this is list of 3, list of 4, list of 5, list of 6. So index starts from 0 to 6. Then here this code is to print the list so the user can see the contents of inside the list. Then we need to find the length of this. Here the length is the number of data, numbers 7. So max index is 7. Then found is set to false, boolean variable, index is set to -1. Then this is equal to read a search value, that's a key element. So this data we need to search from this list. Search value. This is the prompt, okay, message. Then this is the condition because we need to compare. In linear search, the logic is each and every element from the beginning, that is the first element, each till the last element in the list. Each and every element we need to compare with the search value. It is a key value. So for example, if I need to search 7 here, 3 is compared to 7. It's not, yeah. 2 is compared to 7. No, 1 is compared to 7. No, 7 is compared to 7. Yes, both are equal. So search is successful. So value found at, and it displays the location also. So the location actually here it is 4. That is index value plus 1. Here the index position of 7 is 3. Yeah? So we need to add one more because index by default starts from 0. That's why. So for 3 plus 1, 4. 4 position. But in some cases, if we input, for example, 10, 10 is not there. So what happened? 3 compared with 10, no. 2 compared with 10, no. 1, no. 7 compared with 10, no. 6 compared with 10. No, 8 with 10, 9 with 10. Then what happened? The list ends. So in this case, what happened? You need to display value not found. So the search is not successful. So this is the condition for what found not equal to true means if we found if some data we found, if the search is successful, for example the case of 7, the 7, that value exists in that list, so found becomes true here. Look, so in that case this condition becomes false, so it will exit from while loop. Second condition means this, it becomes false when we reach after the end of the list. So when our search finished, when the system compares all the elements in the list, then what happened? There is no list data in that list, so the item is not there. That's the meaning. So this condition becomes false, so it exits from the while loop. Then it will check whether if found equal to true means at first we saw what found is set to false. So when this found becomes true, when the system find some value, then this found becomes true. So if it is true, value found at location, then it prints the location. Otherwise, what happened? What is the meaning of that? Found is false because that item is not inside this list, and this indexed position finish. That means it exceeds. That means here index value increment. Yeah. For example, list of 0. So 0 index is 0, -1 first. Okay, here. So -1 plus 1, 0. So list of 0 is compared with search value. Then what happened? It can check the condition. If the conditions are true, then index becomes 1. So that is 2. 2 compared with the search value. Like that, what list of 1, 2, 3, 4, 5, 6. If it reaches 6, yeah, list of 6 is 9. 9 compared with, for example, if the search value is 10, 9 equal to 10. Oh, that's also false. That is not right. Yeah. So found is not set to true. So what happened here? Found is false. It's not true. So found not equal to true. That is true. And index, what is index value? Our index value is now 0, 1, 2, 3, 4, 5, 6. Yeah. 6 less than, what is max index? 7. 7 minus 1, 6. So 6 less than 6 is false. So what happened? This becomes false. This condition becomes false. But this is true. But this is false. So it exits from the while loop and it prints value not found. The first condition is what? When the computer system finds that value, when search is successful, what happened? Found is set to true. So false changes to true. So this condition becomes false here. This becomes true. So false and true means what it is. False and true means what it is. So here, this condition becomes false when file not equal to true, found not equal to true, when found becomes true. So when it becomes true, when the system finds some value, for example, 7. List of 0, 1, 2, 3, list of 4 equal to 7, yeah? 7, both are same. So found becomes true because 7 is already inside the list. So when it comes here, found true not equal to true, that is false, but this is true. So false and true, we need to use and here always. And means both conditions should be true, then only it executes. Otherwise, if any condition is false, for example, for true and true is true, false and true is false, true and false is false, false and false is also false in the case of and. So if this becomes false, then what happened? False and true. So the entire condition becomes false. So it will exit from this loop because we found some value, that is 7. Then if found equal to true, then it displays the this message value found at location and display the position. That is 7. The position of 7 is 4. Value not found. Otherwise, what happened? Value not found. Okay. So I'm going to run this program. And the number to search. So here 7, yeah. Value found at location 4, yes, 1, 2, 3, 4. So the value is found. That's why search is successful. Then second case. So I need to find 10. Still is not there. So value not found. So linear search, it compares each and every data from the beginning till the end with the search value, and if it compares and if the comparison is true, if a value found, then what happened? It display the position and value found at location message. But if the data is not found, what happened? It prints the message value not found. So it compares each and every value inside the list. Okay, that is the logic behind linear search. Okay, thank you.